Hello and welcome to this talk about BOSH. So we are going to have a short introduction into this fantastic automation technology. So a few words about myself. I'm Julian Fischer, CEO of a company called anynines, and we are focused on Cloud Foundry development, operations, and data service development for Cloud Foundry. So Cloud Foundry is the context of this talk. In particular, we are going to describe the automation technology, BOSH, the preferred methodology of how to operate and deploy Cloud Foundry. So why is that important? Because Cloud Foundry is a distributed system. It consists of many services, around 50 in a production environment. So generally speaking, when operating a platform, the challenge is that the platform operation, including the operation of apps on the platform, together must be easier than doing so without it. Otherwise, it would be pretty pointless. So that leads to the challenge on how to operate a platform at a large scale. And the answer to that is obviously BOSH, because it has been built with platform operations in mind. So what is it? BOSH lets you orchestrate the lifecycle of large-scale deployments of distributed systems being deployed to infrastructure. So what we can say is that given any infrastructure as a service, for example OpenStack, you'll have an API that allows you to automate the creation of virtual machines. And in OpenStack also the creation of virtual data centers, for example. So in this diagram, you can see that there's a virtual machine, and we deployed BOSH on that virtual machine. As we see later, you can also deploy BOSH using multiple virtual machines, but in this case, good enough, there's a single virtual machine. So BOSH actually opens a separate API, so you can talk to BOSH using its API. You can also see that BOSH comes with a adapter that's called the BOSH CPI, which represents the infrastructure-specific implementation required that BOSH can talk to that particular infrastructure. In this case, OpenStack, for example. So whenever you tell BOSH to deploy something, what BOSH will do is subsequently talk to the infrastructure layer and tell him, for example, to create a virtual machine. But more than that, on this virtual machine, there's a BOSH agent that will also set up whatever software you would like to see. For example, PostgreSQL. And as you have seen that a part of the creation of that virtual machine is also the creation of a storage volume and attach that volume as a persistent disk into the virtual machine, because that helps to separate the state of the virtual machine from the ephemeral virtual machine itself. Alright, so as you can see, the virtual machine creation as well as the software configuration is handled by BOSH. And the BOSH deployment can actually comprise many virtual machines and many different software components to be configured. So how does this work? The BOSH architecture consists of several different components, one of which is the BOSH Health Monitor, whose main responsibility is to look at the desired state of a particular deployment and continuously monitor it and check whether the desired state is still equal to the current state. If the current state actually changes, it'll advise the BOSH director to act and change the system state back to the desired state. There's also a component called the NATS message bus, allowing asynchronous communication between all BOSH components. NATS is also the message bus in Cloud Foundry, by the way. The BOSH registry is a small web service that holds and stores the configuration information of virtual machines. which is used while bootstrapping virtual machines. So in that case, BOSH agents located on virtual machines managed by BOSH will talk to the registry and retrieve information, configuration information. As we'll see later in this presentation, that BOSH actually does a lot of software configuration, and this configuration and installation includes, for example, the compilation of source code into binaries. This compiled source code is then stored in a blob store for later reuse. So for example, if you describe a MySQL job, a MySQL package will be compiled into a MySQL binary. And whenever you spin up a virtual machine using BOSH to run MySQL, this MySQL binary that has been compiled will be taken from the blob store. In real-world deployments, a blob store can be configured to use different backends. For example, Amazon S3, OpenStack Swift, or a local or remote local file system, or a remote NFS storage. So BOSH can be placed on a single virtual machine by co-locating all components of BOSH on a single virtual machine, which is then often referred to as micro BOSH. In real-world deployments, it can be necessary to distribute BOSH to several components in order to scale out BOSH, which is not a problem. So you can easily have multiple VMs running BOSH, as BOSH itself is a distributed system. BOSH Automation actually works in a way that it is comprised of so-called BOSH releases, and they contain the blueprint of a distributed system. So that's where the automation actually resides. So you can say that a BOSH deployment actually refers to three different entities that are very important, one of which is the stemcell, a release, and a manifest. So what is a stemcell? A stemcell is part of a deployment. A deployment always refers at some point to a stemcell, and it actually is a virtual machine template. On Amazon, for example, this could be an AMI. But it's not just any virtual machine template. It is a virtual machine template that comes along with a little software component called a BOSH Agent. And the BOSH Agent is a piece of software that knows how to connect to a BOSH director and receiving information what actions to perform on the virtual machine. So the BOSH Agent is exactly the entity that takes out all the changes on the virtual machine, while the BOSH director is the entity that tells the agents what to do. So back to the stemcell. The stemcell is basically nothing more than a virtual machine image and a BOSH agent. And by that, it is often infrastructure specific and operating system specific. So for example, you have a OpenStack SUSE image, or a OpenStack Ubuntu image, or a Amazon Ubuntu image, or a Amazon SUSE image. A BOSH deployment also refers to a release and a manifest, where the release is actually, as mentioned before, the place where the actual automation resides. It is a collection of configuration files, startup scripts, and software packages, and refers and describes to one or more jobs. A job in BOSH is a process to be run and describes how to set up, how to start a process. For example, your MySQL daemon. So in order to spin up a MySQL daemon as a job, you'll have to define how MySQL actually is compiled. And that is done in a package. So BOSH comes with the concept of packages that allow you to store source code and either tell how to compile it and or how to install it. So for example, if that package refers to a Ruby application, you don't need to compile, but you need to store the source code and tell the package how it's actually, how it's later, how the package is installed. How the process is run then is described as a job. If the package, for example, MySQL is a source code that needs to be compiled, a compile script, basically, for example, a simple bash script, is invoked and describes how to get the source code into a binary. A BOSH deployment also contains a manifest. So where the BOSH release is the abstract blueprint, the manifest actually fills in all the necessary blanks in order to describe a concrete deployment. And this, for example, includes the network architecture, for example, the layout of the network, the IP address ranges, and so on, but also important things such as virtual machine dimensions and the stem cell to be used. BOSH, then you can use the BOSH CLI, a command line interface, the main interface you interact with BOSH, to upload the manifest to a BOSH, which then subsequently creates a deployment. So in the end, you're deploying against an infrastructure. In today's demo, we are deploying to my local machine using BOSH Lite, which not uses a infrastructure but creates containers instead of virtual machines. But using OpenStack, vSphere, or Amazon, you'll have to tell BOSH how to access the API of the infrastructure, and that's what you do in the cloud config, which is a good improvement been recently made to BOSH. It helps you to keep your manifest files and your BOSH releases free from infrastructure specific configuration. So it's also important to see that BOSH helps you to deploy your distributed systems, and by doing so, you'll gain a lot of benefits straight away without doing anything. So one of these advantages is infrastructure independence. That means your BOSH release contains the automation, but it is not infrastructure specific in any way. For example, if you deploy your software to Amazon, it does not refer to the Amazon API at all. It uses BOSH's releases and packages and jobs to describe how the software is set up, compiled and run, but by doing so, the abstraction provided by BOSH allows you to use the same automation and run it on OpenStack. So it strictly follows the approach of automate once and deploy everywhere. So you can basically target a certain BOSH running on VMware and just easily deploy a distributed system on VMware. And you can use the same automation to trigger a deployment on AWS or, as you can see, on OpenStack. So, taken down to the level of infrastructure, this means that at some point you have to be specific around infrastructure. And BOSH does that by providing an abstraction called the BOSH CPI, which means Cloud Provider Interface. So the BOSH CPI is a strategy pattern. It's pluggable. All you have to implement is a little more than a dozen methods, including how to create a virtual machine, how to deprovision a virtual machine, how to create a persistent disk, how to attach a persistent disk, and how to do some basic network configuration. So that's actually what's inside of the CPI. And for each supported infrastructure, there's a CPI. So for OpenStack, that is a OpenStack CPI. For Amazon, that's an Amazon CPI. So if your infrastructure is not supported, just create a CPI, and you can use all the existing automation for BOSH and apply it to your infrastructure. So with BOSH, you get a infrastructure independence, and by switching between clouds, all you have to do is use a specific stemcell and adapt your cloud configuration. You can leave and remain your BOSH release untouched. Also, you receive operating system independence because a BOSH release does not depend on the operating system. By describing how you compile a MySQL from scratch into a binary, it is absolutely unimportant whether you do that on Ubuntu or on SUSE. It is pretty much the same script that will be run, and the resulting binary will be stored in the blob store for later use. So you can also imagine of deployments that make use of several stem cells and hence are comprised of different components running on different operating systems easily. So the only dependency that BOSH knows is the stem cell. That's where rubber meets the road. So what's a stem cell? As we've said, a stem cell is basically an operating system image with a virtual machine. So there's a Ubuntu stem cell for OpenStack, for example, or a SUSE stem cell for OpenStack, and a SUSE stem cell for vSphere. And by changing the operating system, all you have to do is change the stem cell and change the manifest file, which refers to the stem cell, but you can keep the same release. Any BOSH deployment you describe, or basically your BOSH release, is inherently scalable, and BOSH makes your deployment scalable in two different ways. It supports horizontal scaling. So for example, when you deploy a component that can be scaled horizontally, let's say a RabbitMQ, all you have to do is to create a release that is aware that cluster nodes have to connect themselves. But once you've done that, all you have to do is change the manifest file and tell BOSH how many virtual machines to deploy. So horizontal scaling, in case your BOSH release and the service you are deploying supports that, it's easy as pie. So scaling out horizontally means you keep the same release, you keep the same stem cell, and you just tweak a few lines in the manifest file. But more than that, some processes also needs vertically scaling. Let's say you have a single instance database and you want to increase the virtual machine and disk size of that particular database. How can you do that while still using it, and also how can you do that in an automated manner? BOSH actually provides a strategy to do that. It's pretty significant. So here in this example, we have 4 gigs of RAM and 1 virtual CPU core and 10 gigabyte of persistent disk. So in this case, we can see Postgres is being deployed, and because we want to keep our data safe, we don't store the data locally on an ephemeral disk, but we do that on a persistent disk. That the data is stored on a remote storage as part of our infrastructure. In order to scale that vertically, what BOSH does is, and you trigger that scale out by just changing the manifest file and telling BOSH that this job now has to run on a different virtual machine flavor. And what BOSH then does in the background is it unmounts the persistent disks, destroys the existing virtual machine, recreates a larger virtual machine, attaches the persistent disk, creates a bigger persistent disk, and copies the data from the smaller to the bigger disk and removes the old disk. So with just a little downtime, you just vertically scaled up a database server. Isn't that incredible? And just to mention, at anynines, we have developed a framework that allows you to create data services based on BOSH deployments pretty easily. And we've created BOSH deployments, BOSH releases that allow you to cluster Postgres. So we perform, using BOSH methodology, we perform rolling upgrades so that one instance after the other is scaled that way. So you can scale a cluster from small virtual machines to large virtual machines, and by triggering failovers during that scale out, you don't have a downtime. Your Postgres database cluster will remain available. All you'll see is 2 failovers, possibly affecting your application with a small hiccup. But there's more to BOSH. Whenever you describe your automation in BOSH, your deployments are totally predictable because BOSH source code, for example, is compiled in freshly created virtual machines. So a virtual machine described by BOSH always contains exactly the software that's specified in a release. There are no leftovers from prior deployments as new virtual machines are used. That's a part why BOSH deployments are repeatable. So whenever you execute a specific BOSH deployment, it'll always lead to exact the same deployed system. So that makes the automation around BOSH, for example, in a data service framework that allows you to create, let's say, Postgres database services automatically, very attractive. But more than that, your BOSH deployments inherently are monitored and self-healing. So whatever you describe with BOSH, you'll automatically heal from process failures. So in a database example, whenever your Postgres process, your Postgres daemon goes away, a process monitor will automatically recognize that, because that's part of the job description, is that the job description will be handed over to a process monitor that will take care of your process and will restart the process in case it just fails. So what if the process monitor itself fails? Then in that case, the BOSH agent will recognize that and restart the process monitor. All right, so on infrastructure, the main challenge often is not that a MySQL daemon goes away or a Postgres daemon goes away, but that virtual machines go away. For example, due to hardware failures on the infrastructure level, infrastructure hosts are failing, virtual machines located on that host go away from one second to the other. So we have to cope with failures of virtual machines. And one way to do that is using BOSH resurrection, who will use the health monitor recognizing the absence of a virtual machine, telling the BOSH director to recreate it, who will then subsequently recreate the virtual machine. And because our data is safely stored on remote storage, we can actually spin up a new virtual machine, reattach our data, and we're good to go. At anynines, we are aware that sometimes data can be corrupted, especially during unexpected failures. So we still recommend to provide some degree of redundancy to your data. So our data services we are deploying with BOSH automatically. They are still clustered and using many or multiple virtual machines to comprise a service instance. But that's a different topic. Of course, a BOSH agent itself could fail, and the BOSH agent is that component that sends heartbeats and exchanges heartbeats with the health monitor. So for BOSH, it's not important whether there's a virtual machine missing or a BOSH agent. The virtual machine will be taken down and recreated. So that's basically all you get for free when using BOSH. So the question comes up, how do you actually use BOSH? And while this talk has limited scope, the the actual workflow and how to do automation with BOSH, I can recommend as a start in this tutorial. It shows you how to go through a very simple deployment and change the deployment. And applying BOSH automation with BOSH follows a simple workflow. So starting with a empty BOSH, you first have to upload a stem cell, the virtual machine image with a BOSH agent that will be used to spin up virtual machines, a release that contains the actual automation, and a manifest that describes how exactly the system is to be built based on your blueprint. Of course, you have to execute deployment in order to trigger the execution of all that. So leading to the question, when do we actually want to use BOSH? Obviously, and looking back into the definition of BOSH, it lets you orchestrate the entire life cycle of large-scale deployments of distributed systems. So lifecycle management and orchestration means that it is comprehensively taking care of everything you need to run software. I have to add here that this is true for software that we deploy to infrastructure, because stateless applications, I will deploy them to the platform and not use BOSH instead. But looking into Postgres databases, for example, it's not a stateless application. A database, per definition, has state. And that actually is something I would like to run on infrastructure. But I don't want to run it on bare infrastructure. And therefore, I'm using BOSH. And with BOSH, I can actually deploy not only single node databases, but also clusters of it. And as you can see with Cloud Foundry itself, it's pretty good in doing so. One use case we actually found out, and I mentioned that earlier, is deploying data services. So we've created a service framework that's purpose is to integrate new data service types as Cloud Foundry services and then integrate them into the Cloud Foundry runtime, so that you can say CF create service and spin up dedicated service instances, dedicated Postgres clusters, dedicated MongoDB clusters, dedicated Postgres single servers, fully automated. So you can choose the size of the virtual machine, and you can choose whether your service instance should be clustered or not. So after looking into various options, we decided to use BOSH as the automation technology. So with that approach, we created a generic service broker, a deployment component that manages BOSH deployments, and using BOSH for the automation. As you can imagine, we gain all the benefits you've seen before. So we can deploy that particular service framework, in this case it's MongoDB as a service, wherever Cloud Foundry runs. On every infrastructure that's supported by Cloud Foundry, that's supported by BOSH, we can also deploy our data services, fully automated, and benefiting from the self-healing capabilities and the operating system independency, without having to do anything for it. All we have to do is create a BOSH release and a small pattern called Service Provider Interface that basically just issues credentials. Now, the most obvious use case of BOSH is to deploy Cloud Foundry, so we'll have a short demo on how this actually works. So thank you for your attention, and let's dive into the demo.